Also, the Arduino will accept DC power in the range of, on the VN plug, from 7 to 12 volts. So this battery and these batteries, these are 8 to 7.5, are going to be fine for powering the Arduino. But here, this is 6 and this is 4.5. So with this, to power the Arduino with 6 volts is going to be uncertain. Even though this car comes with a battery pack like this, I don't know if they intended that to power the Arduino as well. So if you're going to power your motors with only 4 alkaline batteries, either AA or C, then you'll have to have a separate power supply for your Arduino. So I recommend you going to 5 or 6 of the alkaline battery. And so if you want to power both the motors and the Arduino, use 6 alkaline batteries, not 4. Here we have the Maker Fire chassis. You can see I have the top chassis on and the wires for the H-bridge coming through a hole, so I'm going to take that off. We have these wires which need to go to the battery pack, directly to the battery pack. So we're going to wire these wires in parallel with the Arduino. And then we have the control pins. And it's hard to see. We have yellow is ENA, green is EN1, in1, blue is in2, purple is in3, gray is in4, and white is ENB. So for our demonstration today, I'm going to pull ENB and ENA, and I'm going to install the jumpers that came with the H-bridge. They're these little black pieces with a metal jumper across the 2 pins. So we're going to put that back on the ENA and ENB. And what that will do is we'll basically make the motors go at full speed. With them off like this, they won't go at all. ENA and ENB need to be either pulsed or high continuously. So ENA and ENB are used for speed control. And we're just going to put these jumpers on so that they'll be at maximum speed. Easiest way to do it is with a pair of nose pliers or tweezers. I think the trick is just getting it onto the pins and then you can push it down. And you see the 2 pins there shorted out. Now to get a connection to these control pins, I'm just going to use a little male header and plug it into this breadboard. Now, normally these breadboards aren't used to taking pins this size. These are pretty big. They'll fit, then they'll go in. But once you do that, you may damage the pins that you're plugging them into because their diameters are larger than a normal breadboard wire. I'll show you an example. Here's a typical breadboard wire, and here are the pins, and so you can see the breadboard wire is a smaller diameter. I have some of these inexpensive breadboards, and it's just easier to work with a breadboard, so I'm going to burn this one. The other thing we need to make sure of is that we can get a connection here on these pins. So you can see the metal piece is just inside the black insulation, so we should be able to get a connection on these short pins here. And it's not super good, in fact it falls off. So what we're going to do is take our nose pliers and try to push this plastic piece down a bit. Right, so you can see the pins are now starting to move inside the plastic piece. So let's try to get them about halfway. Get that one a little better. Let's see if that works a little better. If you hear a noise in the background, it's rain, which is something we desperately need here where I live. Okay, so hopefully these will now make contact inside the breadboard and it feels pretty good.